Hello, thank you for the introduction. Welcome to the practical limitations of the formal systems. This is the last presentation, and I hope it's not the least worthy of your time and your attention. I hope we can make it fast and not stay up until the end. So this is not going to be a high-level algebra lecture. This is going to be about ambition and about soft skills. But before we get to that, let's try to answer a question, a kind of a different question. How do we know what a program does? It's a general question, so I would expect general answers. So let's start from the general answers. We have this guy, some very strange, potentially malicious program. We don't know what it does. It's signed with a stolen certificate from Realtek that was revoked quite some time ago, but it's presenting itself as a legitimate application, and we want to know what it does. So what do we do? Well, first of all, let's just run it. Let's run it and see what happens. Like, what can go wrong, right? Because why not? We're courageous. Let's just run the program and see what are the effects of that, and cry later. So that's not the way, not because it's unsafe, and obviously it is, but it's not actually answering the question. So we can find other approach. If we have a source code, if we're lucky, if we have a source code, and since we're engineers, most of us are engineers, we can assume that we can understand the source code. So let's look inside and see what it does. Let's understand what it's doing. And we can also combine those two methods. Let's start Visual Studio. Let's start our favorite tools for executable analysis. Let's find out what it's linking to, what tasks from the operating system it's trying to get. And so let's combine running it with trying to analyze its behavior. So all those approaches have a bit of a fine print that's making all those approaches invalid, because they're not answering the question. Well, first of all, if you run the program and it's malicious, even though it has a very beautiful fox icon, well, it cannot hurt us. It may be harmful, but also it does not provide the answer. It might not be visible what the program does. And if we have the source code, we can only assume we understand it. We can only assume it's not obfuscated. And if we use the code analysis tools, well, that might also bring us to nowhere, because the program may be constructed in a way that's intentionally hiding what it's actually doing. So this is not the way. Those are general answers for the general questions, but this is not the way. Let's get a bit more advanced. Let's try something more complicated. Let's go heuristics. Well, antivirus software is getting sold still, so maybe heuristics are working. Let's try to perform a minimal sandboxing. Let's try to start an antivirus software and find out what it thinks about the executable we've encountered. So we have the signature-based detection, but we also have heuristics. So even if it's new, we have some kind of chance that maybe the antivirus is going to tell us that the program we're trying to run is not something we want. But what if this happens? What if antivirus software is telling us that everything is perfect? Well, maybe we are just unlucky with our antivirus software. Let's go deeper. What if this happens? What if every antivirus, and even the experimental ones on the market, are telling us that it's completely safe to run this executable from allegedly 1998 with a stolen certificate, beautiful fox icon, and very strange encrypted embedded resources? Well, we're back at square one. We don't know what a program does. So what we can do to assume what the application is doing? Well, nothing. But since before we state that, let's try to have a bit more fun. Let's try to run it in the virtual machine. Let's go to the square one. Let's try to run in the virtual machine. We're not going to be afraid about what's going to happen with our system. Let's take a look inside, and let's start all the analysis tools that are available to try to look inside. And even if the program is not going to escape the VM, and that can happen, which is beautiful, we still do not have the definitive answer. So you can see that we are performing quite an organizational overhead to actually try to find an answer for a simple question. And it turns out that it's just impossible to know. We cannot know that, ever, with any program. So this is something that's not especially reassuring. So how can we live with that? So how does the world doesn't crumble if we cannot just know what the programs are doing? And apparently we're always assuming what the applications are doing, but never know. How come? How's that possible? Well, let's scream and say, well, apparently it's impossible to create an antivirus, a program that can reliably tell us if something is harmful. Yeah, we know that. We don't like to get reminded of that. But it turns out that this is not because of something is really complex, but this is because something is just plain impossible. This is a beautiful difference we're going to talk about today. And let's go technical and let's go scientific. And in IT, actually, you cannot get any more scientific than Alan Turing. And he defined a halting problem and an ability. He asked a question: is there an algorithm that can be used to predict, maybe not predict, to define, strictly define, whether a program can stop? No, there is no such way. And this is a specific form of some other general problem. But it all can be brought to one sentence that I really enjoy and decided to put on this slide, that the arithmetical truth cannot be defined with arithmetics. This is fantastic. Let's keep that in mind. And let's switch to something completely different. Okay, so we've landed with a reality that does not provide us any actual reliable knowledge. We know nothing, and we're responsible for everything. God forbids we're responsible for IT security, and we are aware of this fact. How to deal with the fact that we cannot answer many questions? That doesn't sound scientific. That doesn't sound like engineering. This is poetry. How can we not define something? I have computers, we have computers can be programmed. This is science. Do not throw the sentences like, I don't know, because it offends me. Yeah. Okay, so the truism is that it's common not to know things, right? This is something that is so obvious that it does not require further explanation. This is by design. People are often telling us, don't worry, it's okay you don't know it, don't stress yourself about it, this is normal. But somehow we tend to easily forget about it, and we try to start a contest. We trying to start a contest of who knows more. If we are faced with a engineering problem, we decide to just get to the bottom of it, because this is engineering. In order to properly solve the problem, we need to understand it, and we are going to look at this problem with a threatening eyes until the bug we're investigating just confesses what's wrong and allows us to fix things and go home. So, since we cannot get the definitive answers, by definition, we are trying our gut feelings. We are trying to use our experience. And that leads to a very interesting phenomenon, like mistaking our knowledge with strong assumptions. We often tend to say, well, I suppose it works that way. I've seen it broken that way, so I'm going to bet that this is the reason that this bug or anything else is just happening. Trust me, I'm a dolphin. And we tend to believe we know something, but in actuality, we're cheating ourselves into believing that we have some secret and sacred knowledge. And this is more dangerous than just assuming we don't know. So that still sounds awfully general. So let's get into specifics. And let's talk about failures. Failures are fun. Let's talk about my failure from my previous job. And a word of explanation, this job has not become previous because of that mistake. This is something I did willingly. So I was put in charge of creating an Active Directory. The Active Directory was to be spanned across the faculty at the university, and it was to be filled with accounts for all the students. So previously, all the machines were being ghosted manually by Norton Ghost using an infrastructure that was much older than it should be. So I decided to create domain, create Active Directory, all the WDS, automated deployments, re-imaging, all this fluff, all this stuff. Everything was fantastic. Also, I created a few thousands of user accounts for the students, but also decided to make it self-managing. Like, I don't want to re-image the software. I will find a way to make it indestructible. I will find a way to secure the system to an extent that will make re-imaging just pointless. There will be no point to re-image the system because it will be so perfect, so secure that nobody in their mind are going to invent a way to get inside. And you probably see where this is going. So, this was the Faculty of Applied Computer Science and Metallurgy. So I was actually throwing a challenge to those people by indirectly telling them, well, can't touch this. You will not harm my machines. But it was not possible to prevent this machine from running any code because they were writing their own software there. So if I prevent all the executables from being run, well, that wouldn't be a nice idea, would it? So I decided to get creative, and I decided to scavenge the internet, all the available resources, to disable everything that can be possibly malicious, even the calculator. Because I found out in some obscure website, obscure blog, I found out that it's possible to exploit the Windows calculator to be a proxy of running executables that will introduce themselves as digitally signed by Microsoft. Yes. So all those things were introduced. The group policies were giant. They were making the login longer because they were being applied to each new logon. And I felt, well, that's it. This machine is indestructible. I fear nothing, fear no one, and I'm going to live forever. So I felt pretty good about myself. The diagnostic tools were saying everything is okay, but it turned out that all the machines were mining cryptocurrencies. All of them. Yeah. So in time, you'll know what it's like to lose, to feel so desperately to be right, but to fail all the same. Yeah, so the destiny caught me. And what happened? What went wrong? And it turned out that I decided to win the contest of who knows more. I decided to know more than the other guy, decided to know more than my boss, and I created a perfect set of a secure environment. But what was going on? Well, there was one guy that was able to solve some task. One guy in the entire year. So he shared his solution to some Russian website. And he spread the link. Guys, this is the website. When you download it from the link, this is the code of our task for this course. So he didn't use Pastebin. He didn't use anything like that. He just zipped the entire Visual Studio solution and put it in some Russian server. Yeah. And this is one of those websites that has multiple download buttons. All of them, except one, are obviously malicious advertising. So it cheated all the users to install a malicious Chrome extension that started mining Monero. And underneath, there was also JavaScript that was mining even more Monero. Yeah. So I won the contest. Yeah, I was technically right. Everything was okay. I decided I need to get to the bottom of the problem, spent atrocious amounts of time to do this, and I was defeated by reality. I was technically right, but so what? This was the example from the university, but this example is going to be a more, maybe it's more familiar. There was a new hire in my current place of work. It was placed in charge of writing a test for a database. Yeah, it was a very big project. The database was provided by someone else. Components were provided by someone else. We only were providing a framework that was installing all this stuff. So if anything in specific was malfunctioning, those teams should have known by their own tests. We were just testing if we can assemble it all together. And we decided that this is an amazing entry-level task for someone who's getting introduced to the product, and we put a new hire in charge of writing tests for that. Yeah. So the question was, well, find out if it's possible to connect to database. So he decided, well, that's great. Let's try to perform some harmless SQL query. If that fails, well, that means it's not working, right? That sounds like a nice test. But maybe if we're assembling the system, even though the configuration is external, maybe we are not installing the service correctly. So let's check that. Let's check if the service is installed correctly. Well, maybe there is something wrong with the network if the service is okay, right? Network is fine? Okay, so maybe let's find out if auditing is saying anything interesting, like hardening, access vector denials. No? Okay, let's find even more. Let's try to ask the audit manager if there is something wrong there. Let's ask the network guys and so on. So, yeah, let's do all this just to find out if we can perform a SQL query. Yeah, better safe than sorry. Yeah, it failed someday. The pull request, by the way, was fantastic because of instead of few lines, it was a Bible of code. Like it was really well written for someone that was a new hire. It was fantastic, but it was just lots of it. Nobody looked about, well, was it in scope? Well, should he have done it? Well, yeah, maybe he should have. Okay, does it work? Yes. Should we merge it? Sure, it's beautifully written. Okay. So finally it failed after hardening. The hardening script has changed, and the database provider team did not customize their installer to take that into account. Yeah. So the new hire asked me, can we go to that team and I will explain them what went wrong. Okay, let's go. Yeah. So we went there, and with this bright spark in his eyes, he started explaining things to them. Like, well, we are trying to install your database, and it didn't work, and I started to find out why, and I written an automated test, and I found out that there is a reason that you are not taking the hardening into consideration. And he was confronted with people that did not start their career in university like me. They looked at him. I was standing perfectly still. They looked at him and asked, well, do you want a medal or something? We know that. We're going to fix our database. Why do you care? Why is it not working? Your work is to assemble it. Why are you testing that? Do you want us to merge your test? What are you trying to discuss here? They were not angry. They just legitimately had no idea why we are coming there. Why? To show that we are awesome? I don't know. So nobody was grateful to him for what he did. And he did a perfect job. And he did not get the medal. So those tests took 3 times as much to write. They did the exact same thing. If something was broken, they said, well, it's impossible, the database is not working, right? Well, the database query was in the bottom. So first he was testing if the entire environment is okay, and if it was okay, he then tried to connect the database. It was the wrong way around. The only thing that was to be done here was to check it, whether it works, and if it doesn't, just start with the blinking red light or something. I don't know. Yeah. So why did it happen? What was wrong? He went out of scope. He wanted to solve the mother of all problems. He didn't want to solve the problem of the testing. He wanted to solve all the problems that he encountered. Why? Because he was a new hire. Since he was a new hire, he wanted to show everyone, listen, I can write the code. I can understand how our infrastructure is working. Let me show that. I will write a code that will make you proud of me. Yeah. So getting out of scope is bad. That's obvious, right? Why we are even talking about it? That's like 101, like, right? Well, because this is about soft skills. We deal with things that are unknown on a daily basis, even in engineering. We have null types, we have undefs, we have entire subroutines that just return nothing or return something we don't care. We have things like pointer to void, which is something that just keeps breaking my mind. We deal with that, we understand that notion. But if we put the notion of unknown things and try to add some ambition into it, well, it becomes much less obvious that it's natural not to know something. So, what are we talking? What's the problem? It's easy to force yourself to try to solve the mother of problems. Experienced programmers want to maintain the state of being an expert. They want to, from time to time, to create a solution that is clever, that solves all the problems, and shows how advanced they are. New hires, for example, tend to be afraid whether they are worthy of being, for example, a junior developer. Like they went past through recruitment, everybody was shouting those difficult terms at them, and they say, maybe someone just made a mistake, maybe I shouldn't be here. I need to try really hard to solve all the problems. So we need to inform our younger peers that it's not about who does the most. It's not about who solves the most difficult problem. And we also need to remember that if we don't know something, that's okay, that's natural, because those are the limits of the formal systems. This is embedded in the very fabric of reality. So failing to understand this open clause nature of the issues leads to the sense of false success. Like with my AD, right? I decided it's impossible that I might not know how to secure my network. I'm a sysadmin. My life has value. I can do it. So I was pretty sure that since I've exhausted all the way of securing systems, all the way of hardening that were described in Microsoft advisories, best practices, all those celebrity hackers on Twitter that from time to time describe some wonderful way of bypassing the security. I was sure that I'm solving the problem, and I got to the bottom of it. And also, our younger friend decided to fall into the pit of over-engineering because he wanted to shake off this feeling of being inadequate, like being not good enough. Yes. We need to remember the software is never really done. So not only we cannot find all the answers we need, we can never solve all the problems we want. It's just not possible, okay? So we need to try to answer those questions. If I'm burning lots of time to solve some problems that interest me, that I decided to get into to the bottom of it, I need to try to decide is it even possible by definition to solve this problem in a manner I keep picturing in my mind? Aren't I going to land in a situation when I've burned lots of time and I'm not even in the middle because this is a road with no end? So if I resign, then at this stage, if I tell myself it's impossible to finish, I'm not saying that I'm incapable of solving a problem. That's the difference that we like forgetting about. We like forgetting about it because it feels good when we solve difficult problems, right? And also our younger peers tend to reach out of scope because they think that the generally asked question should be answered in the most specific way possible because this is engineering. So doesn't sound still obvious, like people are saying, well, I know I shouldn't over-engineer. I've been working at this for years. What are you trying to teach me here? Well, I know it's obvious, but the ease at which comes forgetting this fact. So we can waste lots of our work due to our certainty that we are perfectly capable of solving problems. We can burn lots of time on our nerves trying to prove the world that we are capable of solving other problems. So if we win the contest of who knows more, if we defeat ourselves, we will land in the same situation I landed with Active Directory. And if I try to show my ambition that I'm the worthy heir to the throne, well, we can land in a situation when my friend from work lost lots of time to try to solve the problem, find the answer to a question nobody actually asked. Those are soft skills, and those soft skills are not a joke, they are knowledge. And I guess that's my time. Thank you for your patience, thank you for your attention at the last time slot of today.
Kamil, thank you very much for your presentation. We have a few questions, actually two questions. Yeah. The first is, have you ever opened a suspicious application that damaged your computer? What really happened?
No. Can I answer no? I can. Maybe I did. Nothing visible ever happened to me. But if I want to follow my own presentation and answer this question, I need to remember maybe that happened. I just don't know that my machine was mining bitcoins for some time. Maybe I was just really cold and all those more CPU cycles just felt fuzzy. Yes, if I get a new executable, I tend to try to run it in the virtual machine first because, yeah, I have too much spare time in my life. I tend to avoid running any executables at all. I'm actually very fond of Windows 10 S mode that prevents running any executables outside of the store, which can be pretty hilarious. So, yeah, I did not intentionally harm myself by avoiding that. But if I want to answer this question legitimately and using the bullet points from my presentation, the answer should be, I don't know, and I have no means to answer otherwise ever.
Yeah, thank you. And the last question, Kamil, is how program can go outside VM?
Oh, that's a nice question. There was a vulnerability, for example, in VirtualBox last year, that using shared folders. When shared folders were enabled, let's start again with a valuable answer at the beginning. The answer is, again, I cannot provide you specifics because I don't remember. And now, since your expectations are lower, I can try to answer. There is a vulnerability on VirtualBox. If you had shared folders enabled, there was actually a path that allowed to run executables outside of the virtual machine on Windows. It was part of the sharing protocol, but it was the requests to the shared folders were unsanitized, if I remember correctly. Also, there is a problem in VMware. If you had a floppy drive controller and used Linux, you could send a malicious set of instructions to the floppy controller driver, and they got executed on a host machine. Those are the ways of escaping the VMs. Currently, they are both patched.
Thank you very much, Kamil. That was the last question. Thank you very much for your presentation. So once again, Kamil Dudek on our stage.
Thanks for having me.
Please, big hand for our superstar. And now I want to invite to our stage the author of the most interesting question. I think it's Karol. Karol, please, welcome. I have a book for you. Karol, thank you very much for your active participation and good question. Thank you very much.
Thank you.